Welcome back to our special series on electromagnetism. In this segment, we'll explore the concept of resonant frequencies and their impact on both electronic devices and human health. Joining me are our experts, Brian and Ruth, who will help us understand the relevance of resonant frequencies and how they play a role in our everyday lives. Brian, let's start with you. Can you explain what resonant frequencies are and why they are relevant when trying to interfere with devices?
Certainly, Matthew. Resonant frequencies are specific frequencies at which objects, including electronic components and systems, naturally oscillate with greater amplitude. Many electronic devices have components like circuits, antennas, and oscillators that have specific resonant frequencies. When an external signal matches these frequencies, it can induce unwanted oscillations or overload circuits, potentially disrupting or damaging the device. This is because the components absorb energy more efficiently at their resonant frequency, leading to stronger currents or voltages.
How do resonant frequencies affect the behavior of antennas in electronic devices?
Electronic devices often contain components that can act like antennas, either intentionally or unintentionally. These components resonate at specific frequencies, and when an external signal matches the resonant frequency, it can induce strong currents or voltages. This can lead to interference or malfunction. For example, a Wi-Fi antenna is designed to resonate at the frequency used for Wi-Fi signals, maximizing the efficiency of signal transmission and reception.
Ruth, can you explain how resonant frequencies can impact human health?
Absolutely, Matthew. Different tissues and organs in the human body can resonate at specific frequencies, particularly in the radio frequency, RF, and microwave ranges. For instance, the whole body can resonate at frequencies typically between 30 MHz and 100 MHz, depending on its size and shape. Specific tissues, like brain tissue or muscle, have their own resonant frequencies due to their electrical properties. Exposure to EMFs at these resonant frequencies can cause thermal effects, such as heating of tissues, leading to burns or heat stress. Non-thermal effects can also occur, such as nerve stimulation or interference with normal cellular functions.
What are some practical considerations when it comes to using resonant frequencies to interfere with devices or affect humans?
Practical considerations include the need for accurate frequency matching and sufficient signal power. To effectively target a device or biological system, one must accurately identify the resonant frequency and generate a signal at that frequency with sufficient power. However, signal penetration is also a factor. Lower frequencies penetrate materials like walls and human tissue better but may be less effective at inducing specific effects, while higher frequencies may be attenuated more but can cause more localized effects.
Additionally, there are significant safety and regulatory concerns. Regulatory bodies set exposure limits to protect public health and safety, and intentionally using EM fields to interfere with devices or affect humans raises ethical concerns. Such actions can be harmful and are generally considered unethical and illegal without proper authorization.
Thank you, Brian and Ruth, for providing such detailed insights into resonant frequencies and their impact on electronic devices and human health. In our next segment, we'll discuss adaptive beamforming technology, its applications in jamming scenarios, and the ethical and legal implications of using such technology. Stay tuned as we continue to explore the fascinating world of electromagnetism.